You know, every time you click or swipe or do, well, anything on your phone or computer, there's this invisible force at work. It's kind of like the ghost in the machine, the thing that actually brings all that tech to life. And what are we talking about? Yep, you guessed it, software.
So, have you ever really stopped to think about what makes your computer more than just a box of wires? I mean, really, what's the magic that turns this lump of metal and plastic into something you can use to talk to people, create art, or just watch cat videos? The answer, of course, is software.
And at its most basic level, that's exactly what software is. It's the communication link, it's the translator between you, the human, and your computer. You tell it what you want, and the software turns that into a language the machine can actually understand and, do something with.
Okay, so to really wrap our heads around this, we got to understand that software isn't just this one big single thing. Nah, it's really split into two big worlds. You've got the apps you actually see and use, and then there's the operating systems, the stuff that's running quietly in the background. I love this comparison. Think of it like this. You've got what you see, right? Those are your apps, the tools you're actually clicking on, like your word processor or your photo editor. They're like digital typewriters and paintbrushes. But then there's what you don't see, the part that's working behind the scenes. That's the operating system, and it's the invisible giant that's holding everything else up. Yeah, the operating system, or OS for short, is basically your computer's business manager. Seriously, it's doing all the busy work you never want to think about. It's handling hundreds of little details, like where did I save that file, or do we have enough memory to run this? It's also your security guard, keeping things safe, and it even keeps track of who's allowed to use the computer. It is the silent but absolutely essential foundation for everything.
All right, so if software is this communication link, this translator, how do we actually create it? I mean, how do we speak to the machine? Well, that's where the language of code comes in. And it was invented to solve a really big problem.
And that problem is what people in the industry call the software problem. Basically, building good software is just hard. It's difficult, it takes a ton of work, and it's super expensive. So what was the solution? People started inventing specialized languages, programming languages, to make it way easier and more efficient to tell computers what to do.
And you can really see how this evolved over time. Back in 1957, you had Fortran, which was all about heavy-duty number crunching for things like the space race. Then just a couple of years later, COBOL comes along to help businesses organize all their data. Fast forward to the 70s, and you get C, which was a huge deal for systems programming. That's basically the language used to build the operating systems themselves. It's like writing the instruction manual for that business manager we were just talking about. And then, boom, 1995, the internet is taking off and Java appears, built from the ground up for a world where everything is connected.
Let's actually zoom in on that last one, Java, because it is a fantastic example of how a new programming language can come along and just completely change the game. And there it is, the iconic coffee cup logo. When Java was released back in 1995, it wasn't just another programming language. Nope, it came with this huge, revolutionary promise that was really going to shape the internet as we know it. And this was the promise right here. Write once, run anywhere. What did that even mean? Well, it meant a programmer could write their code just one single time, and that same code would work on a PC, on a Mac, on a phone, you name it. You didn't have to rewrite it for every single different machine. And in a world where everyone had different computers, this was a massive, massive game changer. And how did they pull this off? Well, it was all built on these 5 core goals. They wanted it to be simple and familiar. It had to be tough and secure, robust, so it wouldn't break easily. A big one was being architecture neutral, which is just a fancy way of saying it's portable and can run anywhere. Of course, it had to be fast, high performance. And finally, it needed to be dynamic and flexible. All of these things together are why Java became such a powerhouse on the web. Okay, so we've talked about what software is, the apps and the operating systems, and we've talked about how it's made, with code. Now, let's bring it all back to the real world and see how this stuff actually shows up in your daily life, from the super simple to the really complex. Okay, here's a super simple but perfect example. You ever wonder how your computer knows what color blue is? It's software. A very simple bit of code, like the name blue, or hex code like #0000FF, tells your web browser exactly what color to show you. That's software at its most basic. A simple instruction creating something visual. All right, now let's go from something simple to something way more complex that we've all done, updating our phone's software. Right? You tap a few buttons, it looks easy,
But behind the scenes, it's this whole complicated dance. When you tap that update button in your settings app, you're kicking off this huge process in the operating system. It has to go out, download the new stuff, check to make sure it's legit, install everything, and then restart your whole device. It's a symphony of software, all happening from one little tap.
And to really blow your mind about the scale of this, remember that simple code for a color we just talked about? That simple system of 6 characters can represent, wait for it, over 16.7 million different colors. That is insane. It's an entire universe of possibilities packed into one tiny, elegant piece of software. It just goes to show you how powerful this stuff really is.
And when you boil it all down, that's what software is. It's just a set of instructions. But those instructions can be as simple as make this pixel red, or as mind-bogglingly complex as running the entire operating system of your phone. So it really makes you wonder, doesn't it? If this is what software does for us today, what kind of invisible instructions are going to be shaping our world tomorrow?